Hi, today I'm going to talk about Coax notch filters. What is a Coax notch filter, where is it used, and what is it all about? Okay, I'm going to demonstrate one that we make, one of the notch filters that we do make, and you can grasp the concept of what it's all about. I'm going to use a basic setup. I'm using a portable spectrum analyzer. Of course, I can do it also on this or that spectrum analyzer over there or that one over there, that one over there. So one of the four spectrum analyzers that I have, I can use it. But nonetheless, I've chosen this particular one, and you can see basically already the response on this. I don't know if it's visible. But nonetheless, okay. So the basic setup is we got a generator, which it's got a DC blocking circuitry, and goes into the actual notch filter. Now, what is a notch filter? Notch filter is basically a piece of coax, which is precisely cut to a quarter wavelength of the frequency that you want to attenuate. And it presents basically like a short circuit to that particular frequency. So I feed the signal into a filter via a T-piece. Over here, there is my actual coaxial stub that I just found together, I put together, and then on the third output of the splitter, I just go back into the spectrum analyzer, and spectrum analyzer is connected basically to the PC for easier viewer demonstration. Okay, so now you can already see, and this particular filter that I'm going to demo is approximately between 435, 436 megahertz. Of course, I can trim it to any desired frequency. It's not a problem. Now, this is a real-time display from the actual generator. Now, the reason why it's jumping so much is because it's a real-time. And what happening is that is a white noise that I'm actually very broadband, because I'm sweeping from the generator, adjusted it basically from 1 megahertz to like 3 gigahertz that I'm sweeping the actual signal. And if you look at it very carefully over here, number three, which is that one, it's approximately 435 megahertz, whatever, 6, 7, somewhere around there. But nonetheless, okay, so what I'm going to do is I'm going to click and choose the maximum peak. Now, I display the second trace, so wherever this real time reaches the maximum peak, it stays for a certain while, a certain amount of time, and then it changes accordingly if there is any major changes in the fast sweep. Okay, now what I'm going to even do, I'm going to put even, if you look at it over there, I'm going to click on maximum hold. Maximum hold, it means it holds it till there is a much higher peak and it stays there. Now, to make a bit more, so that's my maximum hold, that's my maximum peak, and the blue one is my basically real time. I'm just going to disconnect real time now display for easier viewing. Now, if you look at it very carefully, okay, now what I'm going to do is, let me just get it over there. You can see I'm sweeping basically from 360 to 510 megahertz, which is from 360 to 510 megahertz over here. And in the center over there, it's approximately, you will see now, let me just do this. Now, number one marker, which is this one here, basically gives me the highest peak, and it's displayed over there. And it gives me approximately at 381 megahertz, about 52, which is my baseline, zero line, you could call it, coming from my generator. Now, if you look at it over there, now I'm just going to put a second marker at approximately minus 3 dB type of thing. So if it's a 52 minus 3 dB would be about 54, 55 dB. dBm. So I'm just going to put the marker, 56, 55, somewhere in the 54, 54, 50. So that's where my second marker is, which is minus 3 dB. That's where the filter actually starts attenuating slowly. And then, of course, we got the third marker that I'm going to enable over there at the desired actual frequency, which is, let's use this one here, the smallest peak, sort of, and that is my center frequency of the notch filter, which is 437. And as I said, I can shift the frequency of the filter this way, or I can, but just for a demo purposes, I'm going to use 437. So I'm displaying basically my marker one is 374, which is the highest peak at 51.5 dBm. My marker 2 is at approximately, which is this one here, that's at 414. And of course, my lowest peak, the highest attenuation of the actual filter, this particular filter, is at exactly 437 megahertz. If you look at it over there, 437 megahertz, which is minus 75. Now what I'm going to do is I'm going to freeze the actual display, and I'm going to try and calculate. So I'm going to say, what is the difference between my highest peak, which is number 1? Okay, so let me just go there. Okay, so I go number 1, and then what is the difference to the actual marker number 3? So I'm going to go to delta marker 3, and that will be approximately, let me just do this, sorry. Okay, so if we basically look at it, so the difference in attenuation between my reference line, which I made it 52 dBm as my zero line, like a reference line, I have attenuated with my notch filter, which is just a piece of coaxial cable, to this particular point, at the minimum point of attenuation at 434, let me just go over there, at 437 megahertz, which is my, say, desired frequency that I want to really attenuate, at 75. So if we say 75 dBm minus something like 52, that gives us something like 23 dBm. 23 dB basically difference. So this filter is actually attenuating something like about 23 dB, the actual whatever interfering signal or whatever signal I would like to attenuate. Now, why does a piece of coax sort of attenuate the signal? Simple. If you look at it, this is the actual one of the notch filters. So I've got the input of my generator. On the T-piece, I've got the signal, the actual stub, they call it, which is a piece of coaxial cable with an open end. In other words, nothing connected at the end over here. And then, of course, I got the signal coming out, now going into the unit that you want to sort of display it on or use it and attenuate the signal at that particular unit to eliminate the signal from that unit. Now, any coaxial cable or any cable, it's got the capacitance and resistance and inductance. And basically, that forms the impedance. And at specific frequencies, depends where the cable is actually cut. Like in our case, that particular cable is being cut at specific sort of length. And at that particular length, the impedance is the highest. The resistance is highest. Basically, inductance is the highest, and so on. And that gives us the highest impedance, which in turn gives us the highest attenuation of the actual unwanted signal. And of course, then what it does, it just lets all other signals through. Now I'm just gonna of course, with any filter, whether it's a notch or bandpass or a stop filter, etc., or for that matter, any inductive sort of device, it has got not only just one resonant frequency, although it's made specifically for that frequency and it's the greatest attenuation there. Most of the devices, as I mentioned, would have multiple different at third harmonics, they call it, at their odd harmonics, they will have attenuation. And the easiest to demo is, I'm just going to increase the basically frequency span from 150 megahertz. If you look at it over here, I'll increase it, say, to 850, and you can see how many peaks in that particular sort of bandwidth, which is from starting 360 to 850, but now, okay, let me just send it. So it's going to be basically from 10 megahertz to 860 megahertz, from 10 megahertz to 860. And as you can see, this is the actual notch filter, okay? Point number 3, which is or 432 whatever megahertz. But we've got 1, 2, 3 peaks. And of course, the greatest attenuation we will always get, okay, this is a very fast real time, so it's very fast, and due to being a white noise generator that I'm sending into the filter, it will fluctuate very fast. However, I'm going to click now maximum peak. Slow down, basically, and I'm going to even go to maximum hold, which is that one over there that I clicked, and I'm going to eliminate the actual blue line, which is the real time, so for easier sort of viewing. So if you look at it, now we got 1, 2, 3 distinct peaks of the actual filter that we been describing and that we've been sort of demoing, which is the piece of coaxial cable. And with this video, basically, I've taken maybe my highest peak of the actual generator and compared it with the minimum peak, the lowest peak of the center frequency that I actually wanted, which is 435 megahertz, if you look at it over there. And that gives me, as I explained, something like 23 dB difference. And the 23 dB, it actually means that I have attenuated unwanted signals, which is 435 megahertz, something like just over 200 times. That's what 23 dBm translated in real time, it actually represents. Something, this point over here is 200 times smaller than this particular point. And 200 times attenuating our RF signal for most of the noise and applications is good enough and strong enough. If we do want, even greater attenuation, because notch filters can give us, and they usually applied maximum up to 30-32 dB attenuation. So if we want to sort of lower increase the attenuation, say to 30 dB or 25 or 27, of course, the amount of attenuation will vary. It will depend on the quality of the coax that one uses, and various sort of, and the specs of that particular coax and so on, capacitance, inductance per meter, and various other things. But in general, if you add another notch filter in parallel, so you have two filters on the same frequency connected in parallel, will give you extra 3 dB, which means I would be able to attenuate it something like 26 dB now, if I added an extra filter. And basically I would double the attenuation of that unwanted frequency, which is 435, to 26 dB attenuation, which would represent something like 400 times attenuation of any unwanted signal at that 435 megahertz. So, in a nutshell, basically, let me go back there to R150. So I'm right now at the maximum peak and maximum hold. And of course, it's all real-time sort of display, which will vary in real time. So I have just demonstrated basically with a simple explanation, I suppose in a simplest form, that I could, that notch filters, yes, they do work, and they are widely used in the RF immaterial of the frequency, whether it's in a gigahertz range or it's HF, radio amateur bands, ultra low frequencies, and so on. So basically what it boils down to is the actual length of this particular stub, of that stub that I'm just sort of showing, that I have just attached it with cable ties and attached it, which is precisely cut and tuned with another spectrum analyzer, one of my other spectrum analyzers, in order to obtain that minimum sort of signal applied over here that comes out over here. And of course it lets all other signals, except this particular signal I'm attenuating at something like 200 times right now with a single notch filter. On that note, thank you for watching, and then till the next video. Thank you very much.